So it's 4:30. I hope you're back from your nice break. And now we can welcome Meister Eduard Gröller, who will give us a talk on how to do a successful PhD in visual computing. So Eddie Gröller is professor at the Institute of Visual Computing and Human-Centered Technology at TU Wien, and he's heading the research unit of computer graphics. He is also a scientific proponent and key researcher of the BioMedVis Research Center and adjunct professor of computer science at the University of Bergen, Norway. His research interests include computer graphics, visualization, and visual computing. He became a fellow of the Eurographics Association in 2009, and he's the recipient of the Eurographics 2015 Outstanding Technical Contributions Award and of the IEEE VGTC 2019 Technical Achievement Award. And if I may add, he's also the academic father, grandfather, and mentor to many of us. He has been a very supportive supervisor of many batches of graduate and undergraduate students, and a very wild-spirited head of the group that motivates people to work hard and also to party harder. So, dear Meister, the floor is yours.
Thank you very much, Renata, for this nice introduction. The grandfather wouldn't have been necessary, I guess. And also thanks for giving away the first part of my talk. I wanted to talk about where I'm coming from, and Renata pointed that out already. But let me give you some details. If I can advance my slides. All right. So I'm coming from the Technical University in Vienna, and there's a faculty of computer science, and within one of these institutes, there's a visualization group in the research unit on computer graphics. So our background is computer graphics, and over the last, let's say, 25 years, we have been a group of about 10 to 15 people, and we have been doing basic research, applied research. We got fundings from various sources like basic research funds, then applied research funds where you need companies. And then there have been various collaborations with companies and other application research units. So our topics are rather diverse. And here I'm just listing these topics. Medical visualization has been a research topic in our area, in our group, for the last 20 plus years. Originally, we started out with visualizing dynamical systems. So you have a system of differential equations, and you are calculating solutions, which are trajectories, curves in a phase space, and you are visualizing those. More recently, under the guidance of Ivan Viola, we were dealing with DNA nanostructures, molecular structures, and so we did also molecular visualization. I think there have been several talks on these topics as well. And Manu and Yun, they are working on graph visualization, abstract data, where many of these data are represented with nodes and edges in between. Also, perception visualization has been a topic where Manu is working on, and also explainability of machine learning and artificial intelligence techniques. Let me, before I go into the core part of my talk, where I will talk about my experiences in supervising PhD students, I will shortly mention a few examples of PhDs that have been done recently in our environment in visual computing, so that you get a feeling for it. The first one is by Daniel Cornell at the BioMedVis Research Center. This is a public-private partnership which is doing applied visualization and visual analytics and virtual reality projects together with companies. And here the idea was to do simulation models in a geospatial context, flooding situations, and then how can you convey these flooding situations where you might not fully know where the flooding is happening, how severe it is, how buildings are impacted. Here you have aggregated representations in color, for example. So this is one example, geospatial data, and you are augmenting that with abstract information that is helping you to solve certain problems. Like in this case, how severe would this building be affected by a certain flooding environment? So let me give you a few video examples. And the first one is where, okay, let me see if I can get this started. You have a large elevation model, and then you do a flooding simulation. And here the difficulty is that you have to use real-world boundary conditions, and you have a very large model that you still need to do a finite element analysis down to maybe a 10-meter squared, for example. The second example in this PhD was how can you then model floods and maybe have in between a realistic representation of the fluids and then encode in certain flood properties, the flow direction, or where there's a turbulent flow and properties like that. And the last example is of, again, a large-scale flooding simulation. So this is has been the PhD thesis of Daniel that kept him busy for 4 to 5 years. The next example is from our group directly, where Tobias Klein has been working on construction of atomistic models in integrative cell biology. On the one hand, you can measure cells from a certain size. You cannot go beyond a certain scale. I mean, this means you're maybe using electron microscopy on the one hand. On the other hand, you can build models, proteins, like what Bara was talking about. In between, if you would like to have information on an entire cell, this mesoscale, you have difficulty in generating the data. On the one hand, from above, you have the measured data, and from below, you have the modeled data. And how can you combine those? Because these models are getting very complex. And the general strategy of Tobias in his thesis was compute instead of store, computing in a procedural manner these models only as far as needed. So you might have an electron microscopy of a virus, for example. Then you can use computer graphics and computer vision techniques to segment this data. And then you take this information here as a sort of statistical information. And these statistics is driving your models that generate detail. And so then you can have these very much detailed models, which you don't see in the electron microscopy. And this model might change over time. And therefore, it's also very important that you can adjust these models to new knowledge that you gain in a very fast way. Here we have seen also when zooming in that the color is changed smoothly. So you need here scale techniques that are adapting depending on the scale what you're using. You are with your navigation, you're going beyond several of these scales. The third example is again more recently coming from the BioMedVis, where Thomas Ortner was combining visual analytics and real-time rendering techniques, and he had 3 approaches. I will not go into all of those with video examples. The first one was you have a tunnel, you want to inspect this tunnel regularly to find out if there are tunnel cracks and how severe they are. And so you have a side-by-side view on the spatial information and the abstract information at the same time. In a second application, it's about constructing new buildings, and there are various possibilities. And how do these possibilities visually impact the important other buildings, certain viewpoints. And so this was a work where you, in a visual analysis way, you can look at various viewpoints, maybe along a railway track, or there are important vista points for tourists, and they should not be impacted too much by these new buildings. And so again, here you had the abstract analysis and the geospatial data. The last one was actually about geologic data, like on Mars. So this was a collaboration where the group at BioMedVis was actually collaborating with the current Mars mission. And then if you have these outcrops, you see various strata in your data, and then you can connect these strata and have this abstract. On the one hand, you have this real display of your geologic formations, and on the other hand, you have these strata that you are showing here. And I have a short video for that, where you have you can interactively interact with the data. You can you have several layers and strata that are representing geologic events, and you are reformatting this. First, you are defining which layers and where you are combining those. You have orientation information that gives you information about geologic processes. And if you are finished with defining these layers, then you can generate your abstract representation, where within each of these layers you have information on the content of the layer, the grain size of the rocks, and so on. So these are typical PhDs that have been done in our environment. But now I think I should talk about more general comments beyond the concrete PhD theses, and that's what I will do. So before you get started, I mean, maybe you're already in your PhD, then hopefully you took these into account. If you think of starting one, the following might be helpful. Why should you do a PhD? I mean, you probably finished your studies already. You have a master or a bachelor, you could live a happy life. Or should you do it for money, for the reputation, or job opportunities? I would say no. I mean, you should be intrinsically interested in doing science. So scientific curiosity is a key ingredient, and that already shows in your master thesis. So if your master thesis has been especially engaging for you, then this might be an indication that you should do a PhD. And some of this information I borrowed from Peter Eads from Australia, who's a well-known graph drawing figure. How to get a PhD? You should find a good topic. It should be engaging to you, and it should be able that you can find new research results. Then likewise, it's very good. It's essential that you find a good supervisor. And then you should use good research methods. And what is really important, you should give lots of good talks. Science is, as I will show in one of the next slides, it's not a very direct process. It's a search process, and you have to bounce off your ideas. And this means you should talk to other people, and maybe hopefully in your local research group, and then you should write a lot of good papers, and at the end you write a good thesis. That sounds very straightforward and very simple, but actually it's not. And how to do research? I mean, research is coming actually from the French, and means rechercher, which means it's an essential research process. It's an intensive research process. There are various flavors of research. You can have a basic research, applied research, and even maybe applied research going in the direction of engineering. So what I'm talking about here is rather tailored to basic research. And Albert Einstein, I mean, not the worst researcher, said, if we knew what it was we were doing, it wouldn't be called research, would it? So it's a little bit an uncertain process that you're doing. And doing the PhD is actually a highly unstructured process. It's an underspecified task. You're talking to your supervisor, and in many cases, maybe he's also very fussy about it. Maybe he usually also doesn't fully know in which direction this work should go. So it's very important that this uncertainty, it's not your fault. It's coming from the task itself. You need to do some structuring at the beginning. And one possibility is to do a divide and conquer. A PhD is an endeavor that takes you 3 to 5 years. So you cannot do it in one large chunk, and maybe at the end somebody's telling you, well, that's not good enough, or you did something totally in the wrong direction. So divide and conquer is something that is very helpful. You should anchor your work in a local research group because you have to interact. There's no absolute ground truth that you can compare what you're doing in many cases. So you need to bounce off your ideas with other people, and the best would be to be embedded in a local research group. And then you should easily get connected in the international research community. Here your supervisor should be of help, because then you need constantly to calibrate. How do I compare to what's going on internationally? So the divide and conquer can be that you divide your 3-year PhD endeavor. First, in a state of the art, you need to find out what the other people have been doing before already. So you need to find the state of the art. That helps you also to find out the research questions. And then you do 4 research projects, 4 to 5 research projects, maybe 6 months each. And at the end of each sub-project, you write up a paper and hope that it is accepted. And usually it will not, because you should submit it to a conference or a journal where you're not sure about if it will be accepted. If you are going to easy events, then you are underselling your results. You should really try to sell them at a level where you are not sure, will it be accepted or not? And if it is not accepted, you revise it, or maybe if it's clear that there are certain things that should be improved or for the moment cannot be improved, then you might go to one lower publication venue. I think it's as a PhD is rather uncertain and fuzzy, you should consider it in many ways as a project. And the project has a starting date, it has an ending date. And as you immediately know that there is a limited resource, you are a limited resource and time is limited. So this means you have to optimize. You immediately, whatever you are doing, you have to think about, is this the most important, most valuable thing that I'm doing? And then for a project, you define the problem. What goal would you like to achieve? Is it a new algorithm, a prototype? And then the approach means, how are you realizing that? Afterwards, you have to evaluate and you have to look at the outcome and also compare the cost. And the cost is not only the algorithm that you're developing maybe, or the research that you're doing. It's also about the hardware, the software that you're using, but also how much it costs you. You are also a resource that has to be taken into account. And then you define milestones. And this is very helpful in a sense to find out if in one of these steps you are highly overdue. And in computer science, there's always this bias that people are grossly underestimating the effort it takes them to achieve a certain task. And for other people, if they give tasks to other people, they are grossly underestimating that. So this is a bias, but you should be aware of that. And by defining milestones, at least you know if at some point something is really getting out of hand. So you should get connected. I mean, why? To steal ideas from one person is plagiarism. To steal from many is research. So plagiarism, taking research results or text parts from other people, is strongly discouraged. It's academic misconduct, and you should be really careful for that. And there are algorithms and software and tools out there where you can check if you are plagiarizing other people. So you have to be really careful, and people became much more sensitive about this in recent years. And you see that repeatedly also high-profile people like politicians have to step down because they were plagiarizing in their PhD. So this is, you have to be very careful, because nowadays, as all this information is digitally available, it's easy to copy. And so if you're putting several ideas together and see it in a new light, that's research. You are standing, or we are standing, on the shoulder of giants. Before us, many other people have done great work. This is a quote by Newton, so I'm trying not to plagiarize this person. So this statement about stealing ideas is attributed to Stephen Wright, but if you actually look it up, it's not clear if he has taken it from somebody else. So even this statement might have been plagiarized by Stephen Wright. Maybe you can take a look at that. So, but getting connected is very important to bounce off your ideas. Because if you're always thinking by yourself, you might end up in a dead end. And it's good to discuss this. So you should have regular meetings with your advisor. Maybe in certain phases, a weekly meeting would be great at the beginning when you're shaping a research idea. Maybe during the implementation phase, less often, meetings are sufficient. And expose your ideas early on to your local peers. Sometimes they don't fully understand what you're explaining to them, but for you having the need to explain it to some other people, you understand your problems in a better way. Sometimes people show up in my office, we discuss their problems. At the end, I'm not fully aware of all the details of their problem, but they seem to be happy because by explaining the problems to me, they were explaining it to them as well. And you should attend scientific meetings early on. Especially local conferences or international conferences. Usually or often a funding agency is paying you a travel to a conference only if you have a paper accepted. And this is not good, because right at the beginning, you should be exposed. What are other people thinking of? What are their ideas? How are they framing their research questions, for example? And then you should attend talks and tutorials. And you should find the fine line of how much talks shall I attend and how much activity then shall I do. So this is a trade-off. And again, thinking of in terms of a project where time is limited helps you that. If you're always only listening to talks, you will not do any research yourself. If you're not listening to any other talks, you might be out of sync of the current research directions. Maybe you are formulating your research questions in the wrong way, or you are repeating work that other people have been doing before. Try to give as many talks. At the beginning, everything is really cumbersome. Preparing a talk takes you ages, but it is really helpful for structuring your thinking. And use every opportunity to get in contact with international colleagues. We have a colloquy cycle, and sometimes where on Friday, local people and also international guests are giving a talk. And sometimes people feel it's a waste of time because the person is talking something about a topic that is not in your direct line of research. But it is really helpful to listen to other people, to experienced people. How are they framing their research questions? And sometimes you get this cross-pollination, and you can take ideas from their work and in a different context for your work, and you easily get a nice new research direction. And the next thing is in the same line, it's about reflection and transparency. I'm coming from computer graphics, and there's a simple model how to simulate how light is interacting with a surface. And you have a viewpoint, you have a surface, you have a normal vector n that is playing a crucial role, and you have a light source. And depending on various angles, you are calculating how much light is coming from a reflective direction, or if you have a transparent surface, also from the transparency direction, you have to take account refraction is ending up in your eye. So, well, this is reflection and transparency. What does this have to do with the PhD thesis? You should be very transparent. So you should clearly know what you're doing. Well, I mean, before Einstein said this is not easy, but therefore you should talk to other people. You should second guess everything what you are doing, and even if you have things that seem to be very obvious, you should take a second look. Sometimes the nicest results or research questions are coming from if somebody is taking a fresh look and is coming up defining new questions from what seems obvious, and clearly communicate this to others to find out if it's also clear to them. And then you do a reflection. Always ask yourself why am I doing this? Why am I selecting these techniques? And always think about, at some point you have to give a talk and you have to justify what you are doing. And if you have a problem in justifying why you selected a parameter, an algorithm, then this might be an indication that you should really think about a little bit more at this case. So transparency and reflection is very crucial in this PhD definition. And it should be internally and externally. And it's a sometimes frustrating process. You are bouncing off your idea, you are very enthusiastic about it, and then you get a feedback, what's novel here? This has been done in a very similar way by somebody else. Yes, but this is helping you shape your idea. And the early on, other people tell you that you have to take a closer look at what others have been doing, the better. And everything is peer-based. I mean, we have a system that is called peer reviewing. You are writing a paper and your peers that are also maybe working on a PhD or just recently got a PhD or maybe are a little bit more senior, they are reviewing your work. And you will also review the work of other people. And I actually encourage you to get into this reviewing process early on. And again, in the beginning, if you review your first paper, you're totally uncertain. You don't know. You have the feeling you are not the expert. You're not in the line of what this person is doing. Yes, but this uncertainty will not go away. If you ask senior people that have been in the field for 5 or 10 years and they are reviewing, and they will still tell you that they're also uncertain to a certain degree. And but they can handle this uncertainty in a better way. And usually several people are asked to review your paper, for example. And then it's also interesting, are they coherent? If several people are pointing out the same issue, maybe they are right. And it's also peer learning. I mean, you don't learn all from your supervisor. Actually, many things you learn from your peers. Ideally, in your group, you have people that are in all stages, different stages time-wise of their PhD. And if you need to prepare a video for your first paper or conference, there should be somebody in the group that already did that. He or she knows the tools much better than you, and they can help you. So this is really a learning. And the supervisor learns also as much as you do. Maybe the supervisor at the beginning is shaping the research direction directly, but in a mentor way, he should over the years getting less and less directing, and you should take over and formulate the directions for your second and third project yourself. Be sincere to yourself and to others. So this is a transparency, crystal clear. If you don't have a good feeling about certain parts in what you are doing, tell other people, ask for advice. And the evaluation is very key, because people and reviewers will always ask, how does this compare? How does this compare to a baseline technique? How does it compare to what other people have been doing? And evaluation can be, there are 3 factors: effectiveness, efficiency, and elegance. I mean, elegance in an algorithm can be a really decisive point if it will be accepted. Elegance can also be simplicity and how it will be adopted by the community. Efficiency is attractable from the resources that are are required. Effectiveness, how closely is it solving what it is intended to do. So here we see for the first time 3 factors. Later on, I will come to a triangular-based worldview, but let's wait and see. And here it's a long quote by Randy Pausch, and unfortunately, this person passed away a couple of years ago, early in his career. That's really unfortunate. But he's talking about criticizing other people. And even if it's a very long one, I want to read it. When you are screwing up and nobody says anything to you anymore, that means they've given up on you. You may not want to hear it, but your critiques are often the ones telling you they still love you and care about you and want to make you better. I'm only criticizing people I really care about. Critique, crisis is coming from, is meaning a time of a decision. Something has to be done about it. And critique is an integral part of what you are doing. It's really good that people locally are criticizing you. If people have to give a talk somewhere in our environment, they give a test talk, and we are really, really picky about the smallest detail. It's really good that the local people are talking about what they don't understand. They are criticizing you, because in the conference there might be many people and they don't care for you, and you do some small things that are not good for your talk, and it could be easy to improve on that. So somebody has to criticize you. Don't worry, don't be frustrated. It's an integral part. Everybody, also the experienced people, are constantly criticized by the others as well. So what's now the key to your success? I was maybe this sounded now a little bit negative. You are criticized, maybe you are frustrated, your submissions are getting rejected. But what's the key to your success? Oh, now I have to cite Shakespeare. You should read Shakespeare. If you can look into the seeds of time and say which grain will grow and which will not, speak then to me. So the future is unclear. And also people are saying predictions are very difficult, especially if they concern the future. This is from Macbeth, and a very nice play, very brutal. Take a look at it. So what's the key to success? It's failure in a way. It means research is a search process. It's not a linear process where you are walking from point A to B because you don't know where point B is. The landscape of the known is convoluted. So you could, here I've used this tree metaphor. Actually, this is a Christmas tree we scanned in a CT some years ago. So research should also be fun. You should really enjoy it in a way. But here the tree serves as a metaphor. The silhouette is the border between the unknown and the known. And so this border is not very clear. It's convoluted. You have many turns and twists. It's even worse. There's no clear border in many cases. It's a swampy region, and you don't know, is this already in the unknown area, or do I don't know, and somebody else far away already was working on that. So the landscape of the known is convoluted. You have to try it again. In hindsight, everything looks straightforward and simple. So if after a couple of years you look back and find many things have fallen into place in a nice way, but if you are right in the middle of it, it's the path that you are walking on is tangled, and you should learn from your errors. Somebody said it's no problem to make an error, but you should not make the same error a second time. And learning from the errors from others is in some ways simpler, because you have a distance and you can see more clearly what they do wrong. If you write a paper, you're so much into it. You should really exploit your co-authors, and you should send them your draft really early on, not 1 or 2 days before the deadline, which is happening very often. This doesn't give them a lot of time to criticize. Sure, this critique can mean that you have to rework your paper, but it's much better that you get these comments internally. And if you cannot fail, you cannot succeed. and sometimes you fail because it's your fault. Later on, I will mention that also a lot of people, they tried again and again. You need this frustration tolerance. And as long as it's you don't know why it does not work, you can give it another try. Let me tell you some failure stories in our WIS group that at the end, well, some failure stories are failures, that they are, you have wasted your time and that's it. But sometimes, and not so rare, it happens. What looks like a bad thing in the short run looks fine in the long run. long time ago, we handed in a project proposal on dynamical systems, and the proposal was thoroughly rejected. We were not the experts, and but we started the WIS group anyway, and the WIS group now exists now for more than 25 years, and all started with a rejected project proposal. The next one is a colleague from our group. He's now well known in the community. He wanted to test the depth of field for volume rendering. I was skeptical because depth of field means you are showing certain parts of the information based on distance in a fuzzy way. But volume rendering itself is presenting certain parts of the structure in a fuzzy way, depending on the transfer function, for example. So you have two different effects that lead to a fuzziness in your image, and it's difficult for the viewer to recognize that. And as I expected, but I let this person work on that. Maybe you could say this was a little bit mean. The results didn't turn out very well, and we were panicking because the deadline was coming up. But so we were thinking, how can we save that? And then we had a string of importance-driven techniques that are mimicking illustrations, cutouts, cutaways. And what started out with an idea which was not so great in the first place, we came up with a couple of interesting publications. Then in this line of research, there was a work which was called Semantic Layers for Illustrative Volume Rendering. And we were proud of that and submitted it to the WIS conference. And there was an anonymous reviewer. And in his statements, he said, in my opinion, this work is a significant step backwards. So, I mean, you can imagine if you are a young researcher and a young author, this is a heavy remark. You know, it's not something like a small step backwards. It's a significant step backwards. But actually, this paper was then accepted at the WIS conference. This is nice. This PhD student is living a happy life now. He got for a second paper also a very interesting reviewer comment. Something like, the result images look interesting, but there's no indication that they were generated by intent. So in a very literature way, a poetic way, the reviewer was saying that we are doing something arbitrarily. But Edison said, I have not failed. I've just found 10,000 ways that won't work. And that's unfortunately in our field not so easy to talk about cases that do not work, because that's a really helpful information for your peer colleagues that they don't go in the same direction. So this is really helpful information. And you have to take these critique and reviewer comments. You have to take them serious, but it's not, you shouldn't take them personally. It's not something about your person, it's about the work. And in most cases, they even want to help you to improve. This colleague, finally, when he got his PhD, he included a cartoon representation in his PhD thesis. You see here this stick figure, and the figure is standing on an abyss, and he's making a step backwards. I think if you're standing at the crevice here and you're in danger of falling down, every step, even a small step backwards, is helpful. Okay, so failure is an integral part of what you're doing. And what is the most valuable resource for your PhD? Well, it's you. So you have to stay focused and dedicated. Are you the right person for a certain problem? Maybe if it takes you another year to learn all the tools, I mean, then maybe you should retarget your research questions. You should act as a problem solver. There are no excuses. I mean, you cannot say my math teacher was really bad and I could not, he didn't teach me right. That's not what counts. It's the result that counts and not the amount of work. It's like competitive sports. If you're lying on the beach and you have a great idea, okay, this is great. And the solutions that you're coming up, if you're the first one, actually you are a trailblazer, then you can get away with the trivial solution. And over time, people are coming up with more complicated solutions. They are refining their approaches. Ultimately, the idea would be to come up with a simple solution, which is should not be mixed up with a trivial one. A simple one, it's easy, it works, people can use it. And again, always you should think about the cost-benefit curve. There is this concept in the economy of the diminishing returns. At some point, it doesn't pay off to improve in a certain direction because you're investing a lot of cost and the benefit is small. So you also should be aware of how far or how strong can I improve something? Is it a factor of 2 that I can achieve? And if I achieve 1.9, this is really great. But if the potential, but the potential is not big, 2 is not much. And if you have a potential that you can speed up something by a factor of 10, and you achieve just half of it, it's a factor of 5. This is great. So think of this cost benefit. And well, lying on the beach and having great ideas, yes, that might happen. But genius is 1% inspiration and 99% perspiration. It's hard work. Initially, have an idea and think about it, how you can target and retarget, but then you have to work really hard. And your competitors internationally, they are bright and they're also hardworking. So you are in a really fierce competition and you have to stay really focused to the point, how can I strengthen my story and my idea? And this brings me to the Pareto Principle. Pareto was an Italian researcher, and he came up with this 80-20 rule, and that is applied in very many situations. And I don't know if everybody was testing if it works, but in these cases, actually with these factors, but it means with 20% effort, you achieve already 80% of your goal. But for the rest, it takes for the remaining 20% that you would like to achieve, it's a whole lot of effort. Imagine if you're preparing PowerPoint slides, a talk, you're pretty much finished very fast, and then you're starting polishing, and this polishing is maybe only 10–20% of the value of your talk, and it takes you an incredible amount of time. So the Pareto Principle is a blessing because in some cases you can make use of it. When you're looking for a state of the art, you have to stop at some point. You cannot read all the related literature. But what is the relevant one? So maybe you do a structured reading. You are writing down, what did I learn from the paper? What's the story? And so on. And maybe you keep a record of your research activities. On the way, you have a great idea, but you cannot follow on that for the moment. That would deviate too much. Write it up. Engineers have a research diary where they're writing up these ideas. And sometimes the Pareto Principle is a curse, because you have to really look at the smallest detail. And if you don't look at the smallest detail, and 110% is barely enough, you will not come to the really interesting questions. You're brushing over and you're not getting down to what is really interesting. Make everything as simple as possible, but not simpler. Again, Albert giving us a good advice. Learn to write good scientific papers. And your paper have to tell a story. It's a publication, which means it has to address a certain group of people. And you should think about which people are these. Again, if you're giving a talk, you should think about what is this audience? What are they educated at? What do they want to know? So you have to really carefully think about that. And then how are you telling this? What is the punchline? And then writing a paper, there are some mechanical things like take a hierarchical top-down approach, define your section headings first, think about how extensive the individual sections shall be. The state of the art cannot be 5 pages in a 10-page paper, for example. Then think about which figures you are including. Actually, you should include figures, and the major components in your paper should be represented by a figure. And just looking at the figure and the captions, your story should be told. And paper writing is a collaborative effort, and include other co-authors early on, and let them write some parts, and maybe give them some parts to review. And you review papers from the others, because then you will see where they have gaps in their story. And then, well, there's a special relationship between the PhD student and PhD advisor. And what is a good PhD student? You should be curious, and you should know your tools. In our area, you should have this analytic reasoning. You should be able to subdivide your problem in individual parts. Then you should be creative, learning on the job in a fast way. And I think this is really important, this resilience and frustration tolerance. You will be frustrated by the technique, by by other colleagues, by the reviewers, but what you should say, I want to learn from that. What's a good PhD advisor? He should be strongly interested in your research work. He should be scientifically well connected and have a strong scientific standing. And he should provide you continuous support. He should let you grow in a way, but should help you that you avoid pitfalls where you are then wasting your time. And then I will talk about these runners if in the next slides. So somebody was saying first-class people hire first-class people, second-class people hire third-class people, and third-class people hire fifth-class people. I like to hire people that are better than me. Well, maybe this is not so difficult, because I like to learn from these people, and I don't have any problem of learning. So don't consider other people competitors. If you have to see them as competitors in your local group, then you have a problem. At the end, I want to come to certain trinities that describe how to run a successful research group. And this is sort of a visual aggregation of what I have experienced in the last 10, 20 years. So if you are and everything for me is a triangle. We are coming from computer graphics, a triangle play a big role. And if you're a research group, you need a group of people, you need an area that is uniting them, a research area, and then they should do something so that they can exist in the long run. So the area in our case, it's visualization. And Sylvia Miksch has this triangle. You have a data, and a user would like to do something with it, wants to get additional knowledge. So you have this triangular representation of your area. But what's more interesting is how does the group consist of? A group consists in many cases of several people. They are doing research projects together, and then they want to produce papers out of it. And you can start, if you would like to get a group going, in each of these corners. And so this is the triple P triangle. And the success is defined. You need to have papers done by people and projects. If you start with people, if you manage that, they should do projects, and then papers will come. If you have papers, you are well known and people want to work with you together, and so on. So this is this corner. And if you look at the paper, a paper is basically a triple I object. So it has to be original. So originality or imagination means this is distinguishing your paper from what others have been doing. The impact is the relevance. How relevant is this? Is this solving a real world problem, for example? And implementation means how can it be realized? Is it easily possible? If you think of people, we have here a scientist, and that is characterized by the triple C triangle. It should be a creative person. In all the technical disciplines, creativity in research is key. It should be a person that is competent and cooperative. So these is the key. But actually, for a PhD, the output, here you have the triple S triangle. You need a supervisor and a student that have joint interest. They want to work together and they have to get along very well. And they need the necessary sources. You cannot do a PhD on the sideline. It's a full-time job. I mean, there are other triangles. I can share the slides. In my triangular worldviews, where you are publishing, there are international, local, or fake conferences. If you want to found a spin-off company, you need the technology, and usually people from our area are very strong at that, but you need the economic expertise. We are grossly undervaluating that, also financial resources. And here, if you are recruiting, there are three types of people. The runners, if are really, they are talented researchers, they know what's going on. You don't have to care very much for that. The self-runners, these are the self-runners, sorry. The runners, if are those people, if the supervisor is giving good advice, they will have good PhDs. If they don't get a good advice, they will have not very good PhDs or not at all. And these are the majority of people. Only in the absolute top universities, you can expect that their self-runners are prevalent. In a good university, if in a group of 10 people at all times, you have one self-runner, this is great. And then the runners, if this is actually where the supervisor makes the biggest difference. And then you have never runners. There are people that can live happy lives. They can have a decent career in industry, but they will not be good researchers for whatever reason. And there's also some people that do a decent and very nice PhD, but they will not be very successful in industry. They are never runners, and you should not bring these people into this situation of having to work on a PhD where they cannot succeed. So you would like to avoid these people. You would like to get as many self-runners as possible, and mostly you will get runners if, but here you can make the biggest difference. And sometimes it's really rewarding to see how these people develop over a couple of years. So our WIS group has certain specifics. I will not talk about that. Basically, what we are doing is we have a very strong internal social interaction to support people when they get this negative feedback, when they are frustrated, and then we go out and have a beer together and so on. And we have and the senior PhD students act as a role model. And we have an international composition, which is also quite rewarding because you get an international flair. So this brings me to the end. What I can say, solve relevant problems and enjoy your work. I have given here a couple of references where you might take a look. We recently wrote a paper about our group setup. Years ago, a colleague was writing up a paper where he was talking about doing reviewing and these constant reflection that is an integral part. And then I was giving some practical tips and tricks for paper writing, which you might take a look at as well. And at the end, again, let me quote Thomas Alva Edison. I never did a day's work in my life. It was all fun. And with that, I wish you all the best for your PhD, and I'm now open for questions. Thank you.
Thank you very much, Meister. And from what I can see here in our Discord channel, we have lots of questions for you. So we can start answering maybe a couple, and then if you have time, perhaps you can go through the Discord channel and answer to some people. Also, we have a disclaimer that if somebody wants to ask a bit more personal questions, I already got a couple here anonymously. You can send them, for example, to me or to Nuska or to one of our moderators, and then we can also post them here in Discord anonymously. So
okay, I'm sorry, I don't have the Discord channel open. Can you
oh yeah, I will read them for you. Don't worry.
I'm sorry that it took so long. Never
no.
took longer than you have time for. This is a bad habit, and people don't like that.
Okay, so let's start with a question from Yaroslav. What to do if it's too late to find a good topic and it is boring as hell, but you're still fascinated by the field in general?
Then switch. I think staying in a situation that is making you unhappy. It depends. You know, if you just need one more paper and you already have two and you need three, then I think it would be necessary that you go through it and finish it. But otherwise, I think this is only making you unhappy. And if you are not happy with the topic, and if it's boring to you, you cannot do good work. So I don't know the concrete situation, but if it's rather at the beginning, switch. I mean, this is the best time of your life. I mean, you should not spend 4 years in a way that is then frustrating you more. Actually, nowadays, a PhD is an enriching and joyful experience. But if it's frustrating you, get out of it. You can do a lot of things in startup companies, small companies, where they don't care for your formal qualification.
Okay, I think this covers the question. The next one would be, I am looking for PhDs in science visualization, generally interested in developing new visualization techniques for biological phenomena. But my background is in biology and anatomy. Most PhDs I've seen are looking for computer science and engineering backgrounds, as though it is easier for a computer science graduate to learn biology than the other way around. Any suggestions?
Well, I mean, there are certain mailing lists where all of these PhD positions, rather from the computer science part, are announced. And sometimes groups are actually interested in this interdisciplinary setup, where if you take somebody in that is not in your area of expertise, this can be very fruitful. It might be at the beginning a little bit more harder, but I think nowadays the really interesting problem are interdisciplinary by nature, but it's not so easy, and you should have to be careful when you enter such a setting. But I think in the future we will see more of these cross area setups.
Okay, good. So I'm getting some anonymous questions in the meantime, so it is hard to keep track of everything. Just a moment. So the next question would be, how hard is it to start a PhD in visualization? I have heard some horror stories in the general discourse where people get rejected left and right, and it seems sometimes it can be very competitive. Is that true in general or in the visualization field specifically?
It's if you want to do international competitive research, the competition is very, very fierce in all fields. But there are certain fields where when a field starts up as new, it might be easier to get something going, as opposed if you're entering a field that is also already very mature. So this is at the beginning the task of the supervisor, to steer you to research questions where you can be successful. And the idea is that you throw in your result at the highest level where you have the feeling it could make it. And if it is rejected, you go to a lower level and you submit it maybe to a second level conference or to a local level. Maybe at the beginning it would be interesting that you start up, that you have a positive experience, not with the highest level of a conference or a journal, but whatever research field, if you want to be internationally successful, it's very competitive, but still there are ways to to help you in that, and that you can succeed. Not all of, you know, not all of the, most of the work is done is not, will not get a Nobel Prize, but you have to steer together with your supervisor at the border what you can achieve, so that sometimes you have your success stories, and then you can have your PhD.
I think this goes very well along the lines of the next question. Where do you draw the line between developing a novel visualization that gets accepted in a journal and creating something useful for users in their actual work?
This is a very interesting question, and sometimes, again, as in the previous question, if you have an interdisciplinary setting, people tend to keep to their community, and they have maybe application papers, as we have in the WIS community, but there it would be great to have applied papers, something like that your domain expert is really using in a daily setting, where the visualization techniques might not be so original, but they are strong on impact. And you are right that sometimes this work is a little bit underrated and it's difficult to sell it. Maybe you can sell it then in events in the domain area, and I think it's absolutely necessary to approach this, because we have a gap between what you do in basic research and how much is ending up actually in the clinical setting and the routine. But this is not so easy.
If Meister, you don't mind, and also the participants, I would ask one or two more questions, stealing 5 minutes from the break, because I actually see that we have a lot of questions here. But if somebody wants to go on a break already, feel free. So do you have any advice for dealing with burnout during a PhD? What can an advisor do to prevent it? And what can PhD students do to support their peers?
This is a difficult question. You should avoid it to begin with. In many cases, people can only be successful in self-exploiting themselves. And I think before a deadline, you have to work really hard, maybe before this deadline at the end of March. But this is not sustainable, and it should not be sustainable. Afterwards, you should have a period, and your supervisor actually should give you a period where you can relax and you can recharge. And you should consciously, as I said, you are the most valuable resource for your PhD. And it serves nobody if you get 2 perfect papers published and then you drop out. So you have to carefully look at you. You have to carefully, I think you should have at least 1 day a week or 1 day and a half free. I mean, even if it's so urgent and you would like to work on that, so really, you really have to monitor yourself. And if there are signs that you are overworked, you should cut back, even if you are missing a deadline. Somebody said, if I'm really in a hectic during the day, I'm taking 1 hour off. And if I'm very, very much in hectic, I'm taking 2 hours off. So really consciously think about, can you do something differently on the weekend? Do some hiking, do some, well, I like hiking, but do some, have some other hobby, and really make sure that you regularly meet your friends and you regularly do your hobbies, irrespective how hectic it is. If it's before the WIS deadline, well, yes, maybe work for 2 weeks or 3 weeks over the weekends, but then stop it immediately and go back.
And then I would just ask the last one, and for the remaining questions that are a lot, it would be very nice if you can go to Discord afterwards. are there any good resources for doing PhD in this field? Like, what are the most important conferences, journals? How to become a peer reviewer? Any unwritten rules?
Several people have compiled some link collections. If somebody is joining our group, I'm distributing this link collection. So if you write me an email, I could send you these link collections. So I'm giving also, and there you said you get an information on what are the most important conferences. It's the WIS conference, it's the IEEE, it's the EuroWIS conference, maybe Pacific WIS, it's the TVCG journal. And then EuroWIS, they're having state-of-the-art reports. I think this is a very helpful resources. Ming Chen, for example, the previous editor of Computer Graphics Forum, has an electronic collection of all these links. Bob Laramie has a link collection. Sylvia Miksch has a link collection on interesting. So there are a few of those. If you drop me a line, I can give you a collection of these links.
Okay. So with this, I think let's conclude this session for now. There is still a lot going on Discord, and people keep asking things. Also, some people are asking about staying or leaving academia, and I have added a link of a previous panel that was held last year at WIS, which might be helpful on why should you stay in academia or not. So thank you very much, Meister, again for this talk and for being with us today. And let's go on a break now.
I'm sorry that I took too long. I will go to the Discord channel and answer those questions. But you can also drop me a line, and we can have an email conversation. Sorry for taking away the break from you. I mean, this is usually you should not do. This is horrible.
Meister, will you be at the social event tonight?
Yes.
Okay, then you have a chance to talk to Meister also tonight.
Yeah, do it fast. I have my bottle of schnapps with me.
Okay. Okay, let's go on a break.
Thank you.
Thank you.